Okay, this is just a really short video to give you an introduction on what these systems are. These are built by Eagle Bergman for Enterprise for the ATEX pipeline. There's going to be one of these for each pump out at the pumping stations. So what I'm going to do is just give you a real brief idea of what these do, and then some of the critical features that you'd want to see. Okay, so first off, just a couple of safety things. If you were to walk up to this, this is an electric box. So you've got high voltage electricity coming into here. These are three-phase motors. So you have electricity here. Not all, but most of this is at pressures exceeding 1200, in some cases 2500 psi. We'll talk more about these in a second, but these accumulators are pressure reservoirs, kind of like balloons. So if these are unvalved, they're gonna spray for quite some time. And then of course, if you're gonna move it around, there's 4 lifting lugs. If you look at the drawing, we point out where the center of gravity is. It's somewhere between here. And of course, if you're gonna move this around, you need proper rigging to do so. Okay, so what is this thing and what does it do? Well, if you can imagine, if you're at the pumping station, I'm going to guess the main process, centrifugal pump and motor, is going to be here somewhere. And on each end of the pump, there's going to be a mechanical seal, and a dual mechanical seal. So what all of this does is provide a clean, cool, pressurized sealing fluid. In this case, that sealing fluid is a mixture of ethylene glycol and water. So again, clean, cool, pressurized fluid to the mechanical seals. The goal here is to supply a sealed pressure greater than suction pressure of the pump. What that does is it prevents any of the process fluid from getting backed up into this system, or more importantly, going to atmosphere. So that's really what all of this does. Now, it looks like one system. It's really 2 different systems on one platform. Now let's talk about what each system is. Starting from the beginning, if you were to draw a line about right through here, right around here, this is what Bergman refers to as an SPN system. What it is, this supplies the pressure, and it refills fluid as that fluid leaks across the mechanical seals. So really, you could refer to all of this as the refill unit. So let's walk through kind of from beginning to end how the refill unit works. First of all this is your barrier fluid reservoir. It's completely unpressurized. Think of this as just a gas tank. It's got some inspection openings. There's some instrumentation on top. What you do in the field is you would pour your barrier fluid into the filler and breather cap. You fill this up to about here with your glycol water mix. Now, one thing that's critical, you have to have this, you can't run down all the fluid out of this. If you do that, you're going to starve the pumps and damage them. Even worse, you could starve the mechanical seals of fluid, and you'll destroy both of those seals. That being said, one of the most critical things on the atmospheric tank is this level switch, and this level switch has 2 floats that go down here. If the level goes to the first float, it alarms. If the level goes far enough down, it will actually stop the process pump completely. That's how important the fluid levels in this are. So this is your main pressure switch that can shut down the pump. You also have a level switch. You also have a level transmitter that's redundant to that, so you can read the actual level live time, and also set some redundant alarms here. So So you have atmospheric pressurized fluid. It goes out these ball valves through a small strainer and into the suction of the pump. Now these are positive displacement pumps, and they have real low displacement per stroke. We're talking really cc's per minute, very low. But what they do is they put out a very high pressure. And what these do is they generate the pressure all through here to maintain pressure downstream. As the seals leak, whatever they leak, these pumps will make up to keep pressure. So again, you're going to be coming out of these somewhere between 2,000 and 2,500 psi. Now, one thing important to point out, these pumps do not circulate through any of this. All they do is maintain pressure. That's why they're very, very low flow, very high pressure pumps. Again, all they do is maintain that blanket of pressure by adding a little bit of fluid that's needed. And just like any pump on the suction side, these ball valves must remain open. These are only here to help construction, and then if there's any major offline maintenance that needs to be done. So those have to remain open. So, the reason that there's two pumps, one is the primary pump, one is the secondary pump. If the pressure begins to fall to a point where this pressure transmitter tells the primary pump to start pumping, it will pump up to 2,500 psi. Then as the seals start to leak, that'll slowly go down, 2,500, 2,400, 2,300. When it reaches 1,800 psi, the primary pump comes on. If for some reason that primary pump does not come on and the pressure drops another 100 psi, the secondary pump comes on. And whichever pump's running, it pumps up till 2,500 psi is reached. They cut off and maintain that pressure. And then again, over time, that starts to draw down, down, down. Pumps come back on, pump comes back on, brings it up, and it keeps doing that. So, you walk around to the back here. So what happens once these pumps pump? What they do is they pump through these lines. This is your pressure transmitter. There's the relief valve set at 2,600 psi. There are also internal relief valves inside these pumps. All they do is protect the pumps from damaging themselves. This 2,600 psi prevents the pumps from damaging any of these components. Okay, so here we go out the discharge. Now what you do is you go through a set of duplex filters. Okay, when I say duplex, these are each 90 micron filters. What this allows you to do is keep one closed, keep one open. If for some reason this becomes clogged or needs to be serviced or inspected, you can shut one off, go to the other one without bringing any of the system down. Okay, so now you're just about ready to leave the refill boundary, and you go to the pressure control valves. These are TESCOM regulators. What they do is regulate pressure downstream of the regulators. Now you're getting into the seal pot zone. Just like the duplex filters, there is a primary regulator and a secondary regulator. And what that allows you to do is the same thing. If one of these needs to be serviced, maybe you want to replace the seats or test it, or maybe you think it's faulty, what you can do is shut one off, bypass it, and go to the next one again while everything is in service. So, what do these do? Well, remember, you've got this 2,500 psi pressure blanket coming to right here. What you then do is regulate that down through here. As you adjust the regulator, you will read that pressure on this pressure gauge. And then what you're doing when you're regulating this pressure, we go over here to the seal pot domain. What you're doing by regulating this pressure is you're setting the pressure inside of these seal pots, and that's depending on the exact service and the exact pump. That's going to be between 1200 and 1400 psi. So that 2500 psi coming out of here gives you enough energy to allow these pressure control valves to work, and to work with very low flows. This is the bladder accumulator that's on the refill unit side. And think of these as big balloons. What you have is you have a bladder. It looks just like a bladder inside of here. What you do is you charge that with air or nitrogen. Once it's charged, that bladder fills most of this pressure vessel. Then what happens is as you build the liquid pressure through here, you start to pump liquid into it. What you're doing is squeezing that bladder. And then as you squeeze that bladder, the pressure in this goes up, 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 up. So what does this do? It essentially stores energy. For any reason, if in this system the pressure starts to fall and the control system's not working, what this does is buy you time. This maintains pressure for quite some time as you bleed that, as you bleed the volume out of this. Okay, so now we go back into the seal pot side. Now again, if you remember, our process pump is out here, and we've got mechanical seals on each end. The mechanical seals themselves have circulating features, pumps if you will, built inside them. And what the mechanical seals do is they circulate fluid up into the seal pot. Barrier fluid comes down, 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 and it reaches this flange. It goes back out to the mechanical seal. So this is your mechanical seal circuit, and this is your barrier pressure. Now, what you can't see is inside these are very long helical coils, and those coils keep the barrier fluid cool in here. Most of that is mechanical seal generated heat, maybe some other heat sources for the pump. So imagine this is a big shell and tube heat exchanger. Now, down here you will see these connections. That's where the cooling fluid goes up that coil and keeps your barrier fluid cool. This fluid is actually the process fluid, and it'll come maybe off the first or second stage of the pump. And what this does is it circulates that cool ethane, methane mix, whatever it is. It's going to be at a low temperature. It could be 40, 50 degrees, whatever the pumping temperature is. Whereas the barrier fluid might be 100, 120, 140, depending on the application. So, why is there two of these? There's one for each mechanical seal. And these are identical. The pressure settings will be the same. And if you look back here, just like the bladder accumulator on the refill side, there's a bladder accumulator for each seal pot and each mechanical seal. The purpose of those accumulators is just the same. They buy you time. They store a bunch of pressure energy in case for some reason you start losing that pressure. Those will help you out. Those will only allow the pressure to decrease very slightly as those begin to evacuate. Okay, now something else that's really important. If the barrier fluid in these loops starts to get really, really hot, in our case, if it reaches 250 degrees Fahrenheit, what does that mean? That means we have either lost cooling flow for some reason, or the mechanical seal has been seriously damaged. For example, it's running dry, something else has gone wrong, it's unable to circulate. The temperature inside this tank will start to rise. What you'll see is there are temperature sensors and temperature transmitters at the top and at the bottom. And if any case the temperature inside here gets to 250 degrees Fahrenheit, again, these shut off the process pump. And then you can see on each seal pot there's a pressure transmitter. What that allows you to do is measure pressure in real time. The pressure in these transmitters should be exactly what that gauge reads. And then if you'll notice on each seal pot there's a pressure relief valve. And if you notice, all the pressure relief valves, these two, that one, and the pressure relief from the regulators, they all go back into the atmospheric tank. That way you don't have any residual leakage. What these relief valves do is protect these reservoirs. These are rated to 2100 psi. These are set at 2000 psi. So what these do is they protect overpressure of the reservoirs. Now, one other thing that's important, again, if you imagine the centrifugal process pump out here, on both mechanical seals, on the outboard, on the atmospheric side mechanical seals, as those leak, they will drip down into the bearing saddle, and these pumps they have featured some tubing that's attached to those bearing saddles. They capture the seal leakage, and each end, if you'll see right over here, each end of the pump sends leakage to these ports. And again, leakage is at atmosphere. It comes back into this tank, and that way all of the sealing fluid is contained. And again, since these are atmospheric, if you need to, what you can do is remove these lines, drip them into a bucket or a beaker, and actually measure what your leakage is. The other thing is the mechanical seals leak. Of course, they're going to draw down this liquid level. We talked about that. Probably, you know, for the first couple of days of service, this level is going to need to be monitored, and that's going to dictate how much replacement fluid you're going to have to put in here. As we gain knowledge about the exact pumping station, the health of the pump, some of the conditions of the fluid going through the pump, we'll all get a better idea of what the mechanical seal leakage is going to be, and how often and how much fluid we're going to need to put into the atmosphere. So again, just to summarize, the whole purpose of this is to keep a clean, cool, and pressurized sealing fluid to the mechanical seals, and that pressure has to be above suction pressure at all times, so that none of the process fluid can enter this system or enter the environment. You also note there's a drip pan underneath the refill tank and underneath the pumps. If any leakage should occur, it would reside in this sump. This is all stainless steel. It can be drained here. It can be drained of anything else that falls in here. And then finally, coming back to the atmospheric tank, there's a drain valve on here. You never ever want to open this during service, because you'll drain the fluid out. The pressure switch will activate and it will shut down the process pump. This is only for complete offline maintenance, cleaning, that sort of thing. So that's our system. If you have any questions, you can call Eagle Bergman at area code 713-485-7000 and ask for who your local contact is. You'll get their number and they will respond right away.